What is an altitude? Let's say I have a triangle like this. Let's say it's a right triangle too. Then my altitude is going to be the point from that right angle that is perpendicular to the hypotenuse. So it creates another right triangle. Now here's the thing. Let's say that this is triangle A, B, C, D. I have my big triangle right here, and that's going to be triangle ABC. Triangle A, B, C. B being my right angle. But I also have this smaller triangle inside of here, which is triangle BDC. So I also have triangle BDC. And with BDC, or D is actually my right angle. So that's where I'm going to start. And so B would have to have the same angle degree as A because B is being split. I would also have this triangle ABD, and D would also be my right angle here. A would be the same as it is up there, and B would have the same angle measure as C. And why is that? Well, let's go ahead and just say, for example, that this was 30 degrees and this was 60 degrees. In my big triangle, that would make sense, no problem. I have 90 right here, and then I have 30 and 60. But let's look at ABD, the red triangle. If this is 30 degrees on ABD, then this angle must be 60 degrees. And if C is 60 degrees on BDC, then angle B on this triangle must be 30 degrees. Hence, they add up to be 90 degrees. Once we've got our corresponding sides, we can go ahead and start to find out what equivalent ratios would be. So typically they would give you like two pieces of information. They might tell you that like AB is 4, BC is 3, and they may be asking for what the side of BD is. Well, since I'm given the two legs of ABC, I know I might want to take those two legs of ABC and leverage that to help me out to find out what is going to be this leg right here. Or let's say they were looking for DC. Well, first, I know that I could use Pythagorean theorem to find the side of AC. I would find that out to be 5. And now that I know triangle ABC is going to be 5, 3, 4, then BDC is going to have the same relationship. Only difference is on BDC, BC is 3. On ABD, AB is 4. And if I was trying to find DC, I'd be looking for this. So my ratio to find that would be, I would take my hypotenuse on both, so this, and that would be my top. So the fraction of AC to BC equals BC over DC. And transparently, I would actually probably flip it so that what I'm looking for, that question mark, is on top. If I'm looking for DC, I would set up as DC over BC, what I know, and then I would set that equal to BC on this triangle over AC. I could substitute everything that I know in here. I would have DC on top, 3 equals, BC is 3, this is 5. And so in order to find DC, I would multiply both sides by 3, and I would find out that DC equals 9 over 5. Well, knowing that, then AD must equal 16 over 5, so that they add up and give me 25 over 5, which is 5. And I can find out all the other angle ratios if I wanted to. Let's say I wanted to find what BD was. So now I'm looking for BD. Well, let's think about my angle ratio. I'm looking for BD, so I would think, what do I know? And we can actually look at BD on this bottom triangle right here too. So BD over what I know on here, which is AB, is going to be equal to what I know on the big triangle, ABC, which is going to be BC over AC. Then if I make my substitutions of what I know, I don't know BD, but I know it's question mark over 4 equals 3 over 5. Multiply by 4 on each side, and I get that BD, my question mark, equals 12 over 5. And that's it for triangle altitudes.